Now, let's continue with the reference angle. Suppose we have such a reference angle, because the reference angle is a positive acute angle, so it must be in the quadrant 1, right? The theta prime is in the quadrant 1. Now, we need to discuss the possibility of the angles which has this theta prime as the reference angle. So which angles can have this theta prime as the reference angle? So the first case is when the theta, this guy, is equal to theta prime plus 2k pi, where k is an integer. So that means theta and theta prime have the same initial side and the terminal side, right? So in this case, theta has theta prime as a reference angle. And then second case is theta is equal to pi minus theta prime. You know this angle, this guy here is equal to pi minus theta prime, because this is theta prime, right? So theta is equal to pi minus theta prime and plus 2k pi. So we know the reference angle is a acute angle formed by the terminal side of the arranged angle and the one of the x-axis, either the positive x-axis or the negative x-axis, right? So now in this case, if your angle theta is equal to pi minus theta prime plus 2k pi, so its position is here, right? It's in the quadrant 2. Then the acute angle formed by this terminal side and one of the x-axis must be this angle, right? So in this case, theta has the theta prime as the reference angle. So this is the second case. Okay. Now, if we add pi to theta prime, so just turn half revolution to here, then this angle, let me use the blue, this guy. So this angle is equal to pi plus theta prime, right? Then any angle which are coterminal with this pi plus theta prime has the theta prime as a reference angle. So we have third case, theta is equal to pi plus theta prime and plus 2k pi. Okay. Then the last case, the fourth case, that is this guy. Let me use the brown. Here. Okay. So this angle is equal to 2 pi minus theta prime, because this one is equal to negative theta prime, right? So this angle marked by this brown arrow is 2 pi minus theta prime. So now in this case we have theta equals 2 pi minus theta prime and then plus 2k pi. So these are the all possible cases in which one angle can have the theta prime as a reference angle. Any question? Now you see, if we have the theta which has the theta prime as a reference angle, then let's look at the cosine and sine of theta. Let's see what kind of values the cosine theta and the sine theta can have. So first, if the theta is here, then cosine theta is equal to x, sine theta is equal to y. If the theta is in the quadrant 2, then cosine theta is equal to negative x and sine theta is equal to y. And if the theta is in the quadrant 3, which has theta prime as the reference angle, then cosine theta is equal to negative x, and sine theta is equal to negative y. If the theta is in the quadrant 4, then cosine theta is equal to x, and sine theta is equal to negative y. So that means if theta has theta prime as the reference angle, and the point of intersection of theta prime with the unit circle is equal to xy, then cosine theta is either equal to x or equal to minus x, or sine theta is equal to positive y or the negative y. So that means we may first use the cosine and sine of the reference angle of angle, and then we use the position of this angle to determine the sine, and we prefix this sine, and then we get the values of the cosine theta and sine theta. So now let's look at some example to see how we use the reference angle and also the position of the arranged angle to find the values of the sine and cosine. So let's look at the problem 50 on page 444. Use reference angles to find the exact value of each expression. Now let's come back to the whiteboard. So it's page 444, problem 50, and we need to find the value of sine of 240 degrees. So if the angle is bigger than 360 degrees or less than the negative 360 degrees, you first try to rewrite this angle as a multiple of 360 degrees plus another angle which is between the 0 and 360 degrees. So right now, our arranged angle theta is equal to 420 degrees. So now this guy is equal to 360 degrees and plus 60 degrees, right? So actually, you just divide the 420 by 360. The quotient is 1 and remainder is equal to 60, right? So right now, we know this angle theta is in the quadrant 1, right? So it is in quadrant 1. I use a QI for the quadrant 1. And then, if you draw the sketch of this angle, then this angle should be like this, right? So just so this is the 420 degrees. Then the reference angle which is formed by the terminal side of this angle and the one of the x-axis, and must be the acute angle. So this reference angle is equal to 60 degrees. So theta prime is equal to 60 degrees. So now that means sine of 420 degrees is equal to sine of 60 degrees up to a sine, right? So right now, for the second step, we need to determine the sine of this value. And we need to use the position of this angle to determine the sine of this sine of 420 degrees. Tell me, in the quadrant 1, what is the sine of the sine theta? Positive, right? In the quadrant 1, you have the both x and y positive. So sine theta is just equal to the y value of the point of intersection. So this guy is positive. So right now, you may just leave this in this form. So we know this guy is equal to sine of 60 degrees. What is the sine of 60 degrees? Root of 3 over 2, right? So you need to memorize this common used angles, okay, sine value. So this is the first example in which we use the reference angle and also the position of this angle to find the exact value of the sine.